All right, in this example, we're going to get down to business and actually take the derivatives. All right, so these are actually the same exact functions we just looked at in example one. Example one, we just broke them apart, right? We just identified the outside function and the inside function. Now we're going to actually take the derivative. All right, so recall that I called the outside function here natural log. Inside function is z, where z is equal to 2x minus 1. All right, so dy dx, the derivative, is equal to, I'm going to take the derivative of the outside function with respect to z. Derivative of natural log is just 1 over z. And now I have to multiply that times the derivative of z with respect to x. Derivative of 2x minus 1 is just 2. Okay. Now I have this expressed in terms of z, but I want it in terms of x. All right. So I want to do a substitution. I'm going to replace z with the 2x minus 1. So what I'm going to end up with is 2 over 2x minus 1. All right. So there we've taken the derivative of natural log of 2x minus 1. All right, so in this one, I noticed I left off a square, so I added that in just to match it, just so it matches with example one. It was supposed to match with example one. All right, so we call q the exponential function e to the z, where z is the inside function, so z is equal to minus 0.25 t squared. All right, so we want dq dt, the derivative with respect to t. So if we take the derivative of e to the z, we get e to the z. And then we want to take the derivative of the inside function. So that's going to give us 2 times the negative 0.25. So that's minus 0.5 t. Okay. So I can just leave it like that, or I could rewrite it. Looks a little nicer if I write it 0.5 t e to the, well, I do need to rewrite it because I need to replace z, all right? I want everything in terms of t, not z. So, so that becomes e to the minus 0.25 t squared. Okay, so that's my derivative. All right, I encourage you to pause the video anytime and work ahead of me, and then I'll just keep going through, so you can always restart the video if you need help with any of these. All right, so let's take the derivative of this. We called v 7z cubed, so z is the inside function, where z is equal to 3t squared plus 4. All right, so we want dv dt. All right, so the derivative of the outside function is going to be 21z squared, and then we want to multiply times the inside function. So I'm going to get 6t, and the derivative of the constant is 0. All right, so let's clean that up again because we need to replace the z. So, and I'm going to, while I'm at it, I might as well take 21 times 6, right? Actually, maybe I'll write it down here. So I get 126 t, and then I need to replace the z with 3t squared plus 4 quantities squared. All right. So let's take a look at this last one. We call a pi z squared, where z is the inside function, which is 3r minus 2. Okay, so if I want dA dr, then I need to take the derivative of the outside function, which is going to be 2 pi z, right? And then I need to multiply it times the derivative of the inside function, which is going to give me just 3, right? Now I need to replace z, so I get 2 pi. Actually, why don't I combine the 2 and the 3? That would be better. I'll write it as 6 pi, and then times the quantity. Don't forget your parentheses here. 3r minus 2. Okay, That's my final answer. All right, so I'll meet you in the next video.